We are team number 4, and today we are presenting our lab report and our lab practice that is called Molecular Chaos. And for an introduction, we have the three laws that we will be using for our experiments. So, the first one, that is Charles' law, states that the Kelvin temperature of a gas is directly related to the volume. So, for every law, we will be using four constants, but not every law will be using all of them in one. So, first we have that P and N are constant. So, we are going to use temperature and volume. So, we have that if the volume increases, the temperature will increase too. So they are proportional. And we have that the formula will be V1 over T1 equals V2 over T2. Obviously, it can be rearranged depending on what variable we want to isolate or find. And the units of measurement for this law will be liters, milliliters, and for the volume, and for the temperature will be Kelvin. And now we have Avogadro's law. This law states that the volume of a gas is directly related to the number of moles of a gas. So, this time, temperature and pressure will be constant. This leaves us with volume and amount. So, the formula will be V1 over N1 equals V2 over N2. And the units of measurement will be liters and milliliters for the volume and moles for the amount. And finally, we have the ideal gas law. This law says that there is a relationship between the four properties that we've been using before with the previous laws. This means with pressure, volume, amount, and temperature. This equals to R, that is the constant. So we have two versions of the formula. The first one is PV over NT equals R, and the rearranged one is PV equals nRT. And the units of measurement for this law will be for pressure atms and milliliters of mercury, for the volume liters, milliliters, or meters to the square, for the amount or N will be moles, and the temperature Kelvin.
The purpose is to observe how the amount of gas changed the volume, and the research question is how the increase of the amount of gas affects its volume.
Yeah. All right. Hey guys, today we're going to prove the Avogadro's law. So basically, the experiment that we're going to do is that we're going to mix baking soda with vinegar, and this will inflate a balloon. So the material that we're going to use is a funnel. This one is for the vinegar that is going to be in the bottle. And then if we have another funnel that is going to be for the balloons to put the baking soda. So the first step that we're going to do is that put the vinegar on the very carefully, right? So we're going to put this in here, the vinegar. So the vinegar is like around 160 milliliters, and we're going to put now baking soda on the balloon, and use a spoon, use a phone, and this is optional. Wait, I don't know how to. No. No me sale. Ahí. Okay, so after stirring a bit, we're going to use this funnel for putting inside the baking soda. So we're going to add at least like 2 or 3 spoons for this experiment. Wait, wait. No. Okay. Oh. Yeah, okay. So we're going to add bit by bit because the baking soda is a bit uh, like uh, mm, wait, I add like a all right. We're going to add a bit more because it's like a little bit of baking soda. I don't know how much I have, but I guess we're going to add a bit more. I hope that works. Then we are going to put with extreme cautions the balloon in here, in the top of the bottle. So be careful that you don't spill baking soda um, inside of the of the bottle. So basically, we're going to make a reaction with this, and let's get ready for this. Hope doesn't pop. Oh. So basically, what happens in here, since the vinegar is an acid and the baking soda is a base, both of them reacts and they I forgot. They like cancel in an each way in a way that reacts and then makes a chemical reaction between them, and they release carbon dioxide. So basically that's it. And so we have carbon dioxide inside, and yeah. So what happens here is that since the vinegar is an acid and the vinegar the baking soda is a base, they both neutralize each other, and this creates an unstable intermediate that breaks down, creating instantly water, and also like releasing the carbon dioxides that this makes the balloon expand or inflate.
Today we will do an experiment about the ideal gas law, and we will make a reaction happen, and that reaction will produce the carbon dioxide, and we will measure the carbon dioxide in the container. Now that the reaction has taken place, we will measure the volume of the container, and we will measure the volume of the gas released. So here it is. It's roughly 12.5 centimeters, and it's roughly 3.5 centimeters of the gas released. And here we have that the diameter of the cylinder is approximately 8.5. So we will measure, we will use the ideal gas law to measure everything. The results were that the experiment resulted in 198.5 in volume uh, of cubic meters. So we have 0.198.5 in liters. We also have 0.00881 in moles, and the type of gas that released was carbon dioxide. The method and materials were the following. For the materials, we used vinegar, dish soap, tap water, and baking soda. Then for the method, we first made a solution with tap water and baking soda. We put 1 tablespoon of baking soda and then 7 tablespoons of water to make a solution. Then we dissolved. We made a solution of the solution of baking soda and the dish soap that we poured into the container that we wanted to make the reaction happen. And in that container we put dish soap, and the reaction occurred.
Hello, my name is Ivy and I'm gonna do the experiment of Charles' law. What we're gonna need is cold and hot water, plastic bottle, and a balloon. What we're gonna do is that we're gonna put the balloon here on the bottle, and we're just gonna enter the bottle with the balloon into the hot water. This effect happens because the air inside of the bottle heats up and the air molecules gain energy, they expand and move faster. And then if we enter the same bottle with the balloon on the cold water, it contracts because the air molecules lose energy and they move slowly. What we prove with this experiment is that if we have more temperature, we're gonna have more volume, and if we have less temperature, we're gonna have less volume.
So, in this video, I'm going to explain the hypotheses, variables, the materials, the methods, the result, and discussion of the experiment that I demonstrate, that I tried to demonstrate the Avogadro's law. And this was with baking soda and vinegar. So we're going to start with the hypothesis. So my hypothesis is that if we put like baking soda and vinegar to react, so it will produce a carbon dioxide or CO2. So wait, okay. So the balloon will inflate after the reaction. So this is because the number of the gas moles will increase. And Avogadro says, the Avogadro's law states that volume is proportional to the moles that are at a constant temperature and pressure. We're going to pass with variables. So variables is the independent one is going to be the chemical reaction. The dependent variable is going to be the balloon volume. Balloon volume. Then the control ones are going to be the temperature, like the room temperature, the pressure, or like atmospheric temperature, the amount of baking soda, the amount of vinegar, and also like the bottle size. And then we're going to pass with the materials. I use a bottle. It was a plastic bottle. It was the capacity of the bottle was around 600 milliliters. I use a balloon, vinegar. Vinegar, the quantity it was 160 milliliters. Baking soda, it was like 2 to 3 spoons. And I use a funnel, 2 funnels actually, in a measurement cup for the vinegar. Now the methods, it's going to be like step by step. So basically, first we pour the vinegar into the bottle with the help of the funnel and the cup and the measurement cup. Then, with the help of the funnel, I put the tablespoon of baking soda into the balloon, and then after that, I put on the bottle. I put the balloon on the bottle, on the top of the bottle, without dropping baking soda into the vinegar. And then after that, I lift the balloon so it can be like vertically. So the baking soda can like fell to the vinegar, so it will react. And then after that, we watch the balloon inflate, and it also like produce bubbles. We have like the results. The results. So before the reaction, the balloon was empty. It was like flat. And then after the reaction, the balloon was inflated. So it was like approximately around the diameter was around 8 centimeters. So also bottles form, and the bottle like got slightly warm. Now we're going to pass with the discussion. So the reaction produced CO2, which increased the number of moles. Also, like according to Avogadro's law, at a constant pressure and temperature. So the balloon inflated because the volume increased with more gas moles. Also, the hypothesis was confirmed. Also, we have possible errors, like minor errors. So some gas might have leaked, but that's impossible. Uh, Also, uh, there was a bit of baking soda at the bottom of the bottle that was like resting. So also the measurement of the balloon, it's not precise. Now, for the conclusion, this experiment that I realized successfully demonstrates Avogadro's law.